Right, final example for this chapter, which is example 8. Two blocks A and B. This one is 10 kilogram, this one is 30 kilogram. Side by side are in contact with each other, which is this one. They are pushed along a smooth floor with the action of a constant force of magnitude 200 Newton applied to A here. Determine the acceleration of the block as well as the force exerted by A on B. Okay, so now firstly we have to draw the free body diagram lah. Okay, so for the free body diagram, this one we have actually we've did it in the subtopic 4.1, but let me just repeat again lah. Okay, so first is we have to draw separate free body diagram for each object, for each block lah. Okay, so we have the first block. A is here. I mean the weight is there, the weight, and then there's a presence of external force, and then there's a normal force as well, and then there's a contact force, and then for B sama aja, dia ada weight but dia tiada external force saja. So this one pula dia ada tu force due to the contact between the other block and then the normal force. Okay, so this one is the weight MAG, and then this one is the external force. This one is the reaction force by B on A, and then this is the normal force. This one is the weight, and then this one is the force by A on B, and then this one is the normal force. Okay, so that is the free body diagram. And then now we have to find the acceleration of the block. What information do we have? We have the mass for each block, MV 30 kilogram, and then the force is 200 Newton. Okay, so how do we do it? Is we know that the total force at the x component would be equal to ma. Now we have to find the acceleration. Okay, and then we know if we look at this, we can actually see there's only one force at the x component, which is this constant force here. Okay, so because of that, we can just let F equal to ma plus mb times dengan the acceleration. Okay, so this constant force is the only force in the x component. Okay, sebab if we look at this, FBA and FAB, these are equal in magnitude but opposite in direction. So if we were to add these two, they akan equal to 0 juga. So that's why we only consider this value of F here. Okay? Okay. So then we have MA plus MB. This one is F lah. So then you'll get the acceleration of the blocks to be 5 meter per second square. Okay? Right, now final question, question B. We have to find the force exerted by A on B. Okay, so by A on B. For object A, so now for object A, you can either choose one sajalah. You can either choose this ataupun this one. Okay, so let's try to do for block A dulu lah. We try to do for block A equal to MAA, right? So now force yang ada is just assuming that the direction of the acceleration is here. So A is there. So then F is positive minus FBA equal to MAA. Okay, so this is 200 minus FBA equal to 10, 5. So FBA is equal to 200 minus 50. then you'll get 150 Newton for the force exerted by A on B, or you can use the other object, which is for MBA. Sama aja jawaban dia. Supposedly sama lah. Kalau salah, kalau tidak sama tu maksudnya kamu ada salah buat. So FAB equal to MBA. So MB is 35, which is 150 Newton. See? Sama kan jawaban dia? 150 dengan 150. So they are equal in magnitude. It's just the direction yang opposite lah. Okay? So that is our final example for chapter 4.